Welcome to my favorite lesson in college algebra, all about circles. Yay! Circles are one of the conic sections along with parabolas, which you guys have already been exposed to, and ellipses and hyperbolas. Ellipses and hyperbolas we'll talk about in a pre-calculus class if you go to take that. But for this class, there are two conic sections we've played with, been parabolas and now circles. If you want to see how the heck it's a conic section, let me go to your textbook page real quick at the beginning of 7.1. And there they have a nice little picture. It shows you how each of those is a conic section. A cone, when you think of a cone, you probably think of an ice cream cone, but in mathematics, when we think of a cone, it looks more like this, where it's like an ice cream cone, two ice cream cones stuck at their points there. That's a cone. And then when you're talking about conic section, you're imagining slicing that cone and seeing what the cross section looks like. If you sliced directly or straight across, like right here, the outline of that little cross section would be a circle. If you tilted your slice just a little, had a little bit of an angle, the cross section would be an ellipse. If you angled it more severely, like this one here, you'd see a parabola, or if you had it straight up and down, vertically going through, you'd see hyperbola. Now, if you were to intersect like right there where the two meet, you would just have a point. Or if you were to, if you were to intersect horizontally right where the two meet, that would be just a point. If you were to intersect horizontally, or not horizontally, if you intersect right along the edge here, the intersection would, or like the plane with that little section would be a line. Or if you did right down the center, instead of hyperbola, you'd end up with two intersecting lines. So it all depends on like how you're crossing those. Those degenerate conic sections they talk about down here, but we're interested today in talking about a circle. So that's where we're heading. Okay, so just talked about conic sections were, and we just looked at page 505 of the textbook. Okay, so we're going to talk about circles. A circle is a set of points in a plane that are equidistant from a fixed point. That fixed point is called the center, and then every single point the same distance from the center makes up the circle. It's a simple closed curve, and called a Jordan curve if you're talking about topology. And it has an inside and an outside, and it's perfectly round. Circles have mesmerized people for ages with their perfect roundness. The distance from the center of the circle out to that set of points is the length of the radius. The distance from one side to the other straight through the center is the length of the diameter. So the diameter is twice the radius, or the radius is half the diameter. And when we go to describe a circle, we can use equations. We've been using equations all through this algebra class. Well, the conic sections are no different. You've already dealt with the equations for parabolas. Now we're going to be dealing with the equation for a circle. Since the length of the radius is really a distance, distance is the length, how far it is to something, we can use the distance formula and derive the equation of the circle. Okay, so I have a circle drawn here, and outlined in black. Blue, it's colored blue for the interior of the circle, and then the exterior is out here in the white area. The center point I've got labeled as h comma k, and then here's the radius I've got labeled as r, and then out here a point on the circle at the end of that radius I've got labeled as x comma y. The radius is going to be greater than 0, and it's a distance, so it's not going to be negative. It's a measurement of length, and it's going to be more than 0 so that you have some kind of obvious circle, just a point. Any point on the circle, x, y, and then here's the distance formula. If you wanted to find the distance from hk to xy, or between any two points, you can use the distance formula. the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You guys learned this formula the first week of class. You can derive the distance formula using Pythagorean theorem. Well, now we can use the distance formula to also go from Pythagorean theorem to distance formula. Now we can go from distance formula to equation of a circle. All right, so let x1, y1 in the distance formula be replaced with hk, the center of the circle, and let x2, y2 in the distance formula be replaced with xy, any old point on the circle. And let the d for distance be replaced with r for radius. So you make those substitutions and you get to here, and then you square both sides and that gets rid of the square root. And now you've got something called the center radius form of the equation of a circle. The h and k make up your center, the r makes up your radius. Okay, so this is the center radius form of the equation of a circle. All right, let's use it. Let's make some equations. Let's say first that you have a circle that has a center at -2, 5. And that has a radius of 4. Okay, so the formula r squared equals x minus h quantity squared plus y minus k quantity squared. And notice that form, the h, there's minus signs in front of the h and k. So the signs of your center are going to be opposite of the signs of what you see in the formula there. Okay, so r squared, so in this case 4 squared equals x minus -2 quantity squared plus y minus 5 quantity squared. So you can say 16 equals x plus 2 quantity squared plus y minus 5 quantity squared. And here's the equation for that particular circle. You have a particular circle where the center is found at -2, 5, and you have a radius of 4. And there it is. Okay. What if your circle has a center at the origin? Well, equations found the same way. No big deal. Center 0, 0, radius of 5. Okay, r squared equals x minus h squared plus y minus k squared. So 5 squared equals x minus 0 squared plus y minus 0 squared. Well, 5 squared is 25. Well, x minus 0 is just x, so you got x squared. Y minus 0 is just y, so you have plus y squared. There's the equation of that circle. It has its center at the origin. So if you see x squared plus y squared equals some number, you know you're dealing with a circle centered at the origin. And whatever that number is, the square root of it will give you your radius. Ooh, next two problems are going to kind of challenge you a little bit. Next one, the circle has a center at 2, -7. But they don't tell us what the radius is. Instead, they say the circle passes through. So in other words, one of the points on the circle is -2, -4. All right, so we don't know what the radius is, but we will be able to figure it out. It's okay. Remember, x and y are just any generic point on the circle. And since they're telling us it passes through -2, -4, that's one of our xy pairs. So yeah, we don't know r yet, but we can find it. We can say, well, we know an x is -2. We know an h is +2, because you got, this is going to be x, this is going to be h, plus we've got a y of -4, minus a k of -7 quantity squared. So you got r squared equals, all right, that's -4 quantity squared plus, well, that's going to be 3 squared. So that's 16 plus 9, or 25. Well, if r squared is 25, r must be 5, the square root of 25. And it's just the positive square root because the r equals a distance. So you can go back now and rewrite your equation. Well, 5 squared is 25 equals x minus h, so x minus 2 quantity squared, plus y minus k, but y minus -7 is going to become y plus 7 quantity squared. And now you've got the equation of your circle. Yay! Okay. Okay, one more weird one, and then we'll start doing some graphing. Yay! This next one, they tell us that the center is at 5, -1. You might notice this time I have a grid here because I'm going to find it helpful. Because they don't tell me the radius, and they don't even tell me where it passes through. Instead, they tell me that it's tangent to the y-axis. So I wanted to draw this on the graph to show you what that means. Okay, center at 5, -1. 1, 2, 3, 4, 5, and then -1. Here's the center. And if it's tangent to the y-axis, that means when you draw the circle, exactly one point is going to touch the y-axis. So in order for that to happen, here's the y-axis, that one point has to be right here. So when you go to draw that circle, this one point right here at 0, -1, the circle goes through it. So knowing that, it's going to be directly, like since the point's over here in quadrant 4 to the right, you're looking directly left, straight to the left, and seeing where it's touching the y-axis. Notice that that tangent point has the same y-coordinate as your center. So that's kind of a little hint too. You don't have to actually draw anything if you don't want to. All right, so going back to r squared equals x minus h quantity squared plus y minus k quantity squared. We don't know what r is, we're going to find it. Well, this point is going to be our x and y, and of course our center is our h and our k. So we got 0 minus 5 quantity squared plus -1 minus a -1 quantity squared. So r squared equals, let's see, -5 squared is going to be 25 plus, well, -1, that's going to be 0. So r is 5. But you know what? I don't even have to do that because if I look at my graph, check it out. 1, 2, 3, 4, 5. Well, the x-coordinate of the center tells me the length of the radius. Notice it's the same as the x-coordinate of the center. So I didn't even need that. So I could go ahead and say, okay, 5 squared is 25 equals x minus 5 quantity squared plus y minus -1. So y plus 1 quantity squared. And there's my equation of my circle. Ta-da! So the center's at 5, -1. You take the opposite signs here, and that'll give you your center. And then square root of 25 gives me the radius, 5. All right, now to graphing. Of course, you knew it had to be coming. By hand, you plot your center, whatever the length of the radius is, just go out 4 points directly to the left of the center, 4 points directly to the right, 4 points with directly left, directly right, directly up, directly down, using the length of the radius to get where that's going to be. And then those 4 points will give you a rough idea where the circle is, connect with the smooth circular curve. If you want to, you can use a compass, make it nice and pretty. By calculator, you need to solve the equation for r, so it means you're going to end up taking both positive and negative square roots, and you're going to have to put one of them in y1 and put one of them in y2 in order to get the complete circle. And I'll show you as we do some. All right, let's start with x squared plus y squared equals 36. Nice little problem where it's centered on the origin. Okay, so our center here is 0, 0. Our radius is the square root of 36, which is 6. Okay, so center's at 0, 0, which is right here. Since the radius is 6, I can go directly to the right. 1, 2, 3, 4, 5, 6. I can go directly to the left. 1, 2, 3, 4, 5, 6. I can go directly up. 1, 2, 3, 4, 5, 6. And I can go directly down. 1, 2, 3, 4, 5, 6. And once I have those points in place, if I was doing this by hand, I'd use a compass, but do your best and sketch something nice and round here. But those points at least give you somewhere. If you're trying to freehand it like I am right now, those points at least give you a reference to work with. I apologize for that not looking very circular, but it's kind of a squished circle, maybe like an orange or something. But anyways, you get the idea. We had a compass. I tried to look, but PowerPoint didn't have a circle drawing tool for my purposes here. We I'm doing this with the pen, so you'll have to just deal with my crappy drawing. But there you go. Now, if you wanted to put it in the calculator, which we'll do that too. Let's look at it in the calculator. You got to take x squared plus y squared equals 36 and solve for y. So you're going to have to take positive and negative square roots. You're going to take them both. And you can do that for y because it's y, not the radius. And then in your calculator, you're going to put one of the square roots in for y1, and you'll put the other square root in for y2. Okay, so let's do it. All right, so first one was square root of 36 minus x squared. Then the second one was negative square root of 36 minus x squared. You might notice that my picture right now doesn't look very circular. It looks kind of elliptical, but that's because of the viewing window right now on the calculator. A viewing window goes from negative 10 to 10 and negative 10 to 10 on x and y, but since it's rectangular, x's are stretched out more than y's. So if I want to have it more circular, what I need to do is change my window. So I'm going to go to zoom, and I'm going to use number 5, z square, and that will even it out, make sure the x's are spaced the same width as the y's. And my new drawing will look more circular. Now, another issue you might notice is that it doesn't look connected right here. That's a limitation from the calculator. It doesn't mean you've done anything wrong. Mathematically, this is a complete circle connected here. It's just the calculator and the way the pixels work, it's not able to finish sketching between here and here. So you need to be aware of that when you're using your calculator. Some of you have newer versions and it will connect the dots. Great, good for you. But for those of you who have older ones, you're going to have like the same problem I'm having, just to warn you. So, but there you go. That's how it goes in the calculator. All right, let's do another example. X plus 2 quantity squared plus y minus 5 quantity squared equals 16. Okay, so r squared is 16, which means r has to be square root of 16, or 4. And then the center, and we're taking the opposite signs of what you see here, the center is going to be -2, +5. Right there. A radius of 4, go directly to the right, 1, 2, 3, 4. Go directly to the left, 1, 2, 3, 4. Go directly up, 1, 2, 3, 4. Go directly down, 1, 2, 3, 4. And once you have your points, you can try to draw a nice circle. Do your best, but unless you have a compass, it won't be perfect. Although my math lab will have a circle drawing tool to help you if you're doing it in my math lab, so no worries there. But you still need to know how to do this. All right, so there you go. Okay, a little bit about domain and range. The domain extends from the x-coordinate of the leftmost point to the x-coordinate of the rightmost point. So your domains, all your possible x's, a circle is continuous and smooth. So if you have from your leftmost point to your rightmost point, you're going to end up using all of those x values. And then the range, from your bottommost point to your topmost point, those y values are going to be your range. So your domain, when you're looking at the x values, you're looking directly left and directly right of your center. Well, whatever your radius is, it's going to be that many units to the left of your center and that many units to the right of your center for your domain. And whatever your range is, it's going to be the radius, those units down from the center, and those units up from the center for your range. Okay, let me show you an example of that. X squared plus y plus 3 squared equals 49. All right, and this one, r is the square root of 49, which is 7. And then the center, well, notice x doesn't have any parentheses, it's just x squared. So the x-coordinate of the center is going to be 0, comma, and then over here you got y plus 3, so 0, comma, -3 for your center. All right, 0, 1, 2, 3. And you're going 7 to the right. 7. So that point's going to put you at 7, comma, -3. You're going 7 to the left. 1, 2, 3, 4, 5, 6, 7. That point's going to put you at -7, comma, -3. So right there, the domain includes the point, those points, and it's going to go from -7 to 7. And then you go down 1, 2, 3, 4, 5, 6, 7. So that actually puts you at 0, comma, -10. And then you go up 1, 2, 3, 4, 5, 6, 7. And that's going to put you at 0, comma, 4. So your range goes from -10 to 4. But notice, like your domain, you're taking the center, h, subtracting the radius, h 0 minus 7, and then taking the center 0 plus the radius 7. Then for your range, you're taking the center's y value, -3 minus the radius, and then -3 plus the radius. And that gives you your range. And you can go ahead and connect the dots. Woo. So you guys are going to be circle graphing fools. Woo. So, but now you see what the domain and range are. And you can go back to your previous examples and you can see domain and range there too. If you go up to this example we did earlier, your domain, your radius was 4, so your domain's going to go -2 minus 4, which is -6, to -2 plus 4, which is +2. And that's exactly these 2 points have those x-coordinates. Your range is going to go 5 minus 4, which is 1, 5 plus 4, which is 9. Well, these 2 coordinates, their y values, give you the range. You can do that with this one too. 0 minus 6, you get -6 to +6 for your domain. You get -6 to +6 for your range. So all that lets you play with domain and range. Okay, and finally, what if the equation of your circle doesn't come in center radius form? What can you do? You know, you can put it into center radius form using something called completing the square. Here's the steps for completing the square. Rather than sit here and read through them, I figure you can stop, pause, read through it yourself on your slides or read through it here on the video. But I'm going to go on next to the next slide, and I'm going to just dive into doing an example and talking you through what those steps are saying to do. Let's say you have an equation that looks like this. X squared plus 8x plus y squared minus 6y plus 16 equals 0. Okay, and this is not in center radius form, but there's a few things that give you your suspicions about thinking it must be the equation of a circle. Well, for one, there's both an x squared and a y squared in this problem. X squared plus 8x, y squared minus 6y. For another, there's a plus here in front of y squared. That's key. You could have a minus, but then it's not a circle. It's another conic section. So that plus sign, there's ones in front of x squared and y squared. All of those things lead me to realize it's a circle. But I want it in the center radius form. So what I'm going to do first is make sure x's and y's are here, but nothing else. So I'm going to go ahead and subtract 16 from both sides. Okay. Then I'm going to look at my x's and y's and make sure there's a 1 in front of x squared and make sure there's a 1 in front of y squared. And there is. There's an understood 1 in front of those, so I don't need to do anything further there. Then I'm going to group my x terms together, and I'm going to leave a little bit of space here because I'm going to need that. Plus, I'm going to group my y terms together. And again, I'm going to leave a little space on the end here before I close the parentheses. What my goal is now is to look at my x terms and get this to be a perfect square trinomial. I'm going to complete the square, make this a perfect square. So I can add or subtract a number here that would make it a perfect square trinomial, just as long as I add or subtract that same number on the right side of the equation. Keep things balanced. Well, to know what to add or subtract, I take half of 8, which is 4, and then I square that. And that tells me what to add. But if I add 16 on the left side of the equation, I need to add 16 on the right side of the equation too. Then over here, half of the coefficient in front of y, which is -6, you're using the coefficient here in the middle, in the front of the y or in front of the x. That's -3. and then I'm squaring that. So I'm adding 9. If I add 9 on the left, I got to add 9 on the right. But now that makes perfect square trinomials. I can factor x squared plus 8x plus 16 into x plus 4 quantity squared. 4 squared is 16 and 4 doubled is 8. Plus, I could factor y squared minus 6y plus 9 into y minus 3 quantity squared. On the right side, it equals 9. There's the equation of my circle. It's the same circle, still it's just a new form of the equation. But now I can very easily see that the circle has a center of -4, comma, +3, and also has a radius of 3. And I can see that from that center radius form now. Yay! Okay, let me do one more of those with you. And I'll leave it up to you to graph it, but plot the center -4, comma, 3, and then go 3 out to the left, 3 to the right, 3 up, 3 down, and then connect the dots. All right, let's do one more. We've got 4x squared plus 4x plus 4y squared minus 16y minus 19 equals 0. Okay, so first things first, we want x's and y's on one side and nothing else. So we'll add that 19 to both sides. Next thing, we want the x squared and y squared terms to have 1's in front of them. If this is a circle, then you'll be able to do this. Since they both have 4 in front of them, divide the entire equation through by 4. So you're going to get x squared plus x plus y squared minus 4y equals 19 over 4. Okay, then group your x's, leave a little space, plus group your y's, leave a little space, that equals 19/4. All right, so completing the square now. Look in front of x, there's a 1. Half of 1 is 1/2, and then you square 1/2, and you get 1/4. So you add 1/4 there, you got to add 1/4 here. And then half of -4, the coefficient in front of y, is going to give you -2. -2 squared is 4. So you're going to add 4 here, add 4 here. Okay, so first perfect square trinomial, we can factor that as x plus 1/2 quantity squared. 1/2 times 1/2 is 1/4, and 1/2 doubled is 1. Perfect square trinomial, y squared minus 4y plus 4 factors into y minus 2 quantity squared. And let's see, 19/4 plus 1/4 is 20/4, which is really 5, and 5 plus 4 is really 9. So there you go. So the equation of a circle, the center is at -1/2, comma 2. The radius is 3. If you're going through this process, and let's say you weren't able to get 1's in front of the x squared and y squared both, then you know it's not a circle. If you're not able to complete the square and get it down into this form, then it's not a circle. If it is a circle, then you will be able to get it down into your circle radius form. You will be able to complete the square. You will be able to get a positive number on this side. Your radius will be greater than 0. So if you think you've completed the square, but you're still stuck with a negative number over here, then you don't have a circle. just to let you know that. All right, well, there you go. I hope you've enjoyed this lesson as much as I have, and happy circle drawing. Bye.